Today, we are diving into the fascinating world of engine technology. In this video, we will explore the differences between naturally aspirated, turbocharged, and supercharged engines. Let's get started. First up, let's talk about naturally aspirated engines. These engines rely solely on atmospheric pressure to draw air into the combustion chamber. No forced induction systems like turbochargers or superchargers are involved. The power output of a naturally aspirated engine is determined by factors such as its displacement and compression ratio. Naturally aspirated engines provide a great balance between power and responsiveness. They deliver power across a broad range of engine speeds, offering excellent throttle response and a smooth power delivery. However, their power output may be limited, especially at higher altitudes or under low atmospheric pressure conditions. Now let's move on to turbocharged engines. These engines employ a turbocharger, a forced induction device driven by the engine's exhaust gases. The turbocharger consists of a turbine, a compressor, which are working together to boost engine performance. The exhaust gases drive the turbine, which in turn spins the compressor. As the compressor rotates, it compresses the incoming air, allowing more air and fuel to be combusted in the cylinders. This results in increased power output and improved performance. One significant advantage of turbocharged engines is the ability to compensate for lower atmospheric pressure at higher altitudes. This means they can maintain power and performance even in challenging conditions. However, they may suffer from turbo lag, a slight delay in power delivery caused by the time it takes for the turbocharger to spool up. Let's talk about supercharged engines. Similar to turbocharged engines, supercharged engines also employ forced induction. However, instead of using exhaust gases, superchargers are mechanically driven by the engine itself. Superchargers, typically driven by a belt connected to the engine crankshaft, compress the incoming air and deliver it to the combustion chamber. This immediate power delivery is an advantage over turbocharging since there's no lag. Supercharger engines can generate more power and torque compared to naturally aspirated engines of the same size. However, it is important to note that superchargers consume some engine power to drive the compressor, which can affect overall engine efficiency. Additionally, superchargers generate more heat, requiring additional cooling measures. In some cases, you can even find engines that combine both turbocharging and supercharging, known as twin-charged engines. This setup provides the benefits of both forced induction methods, resulting in even higher power and performance. So, to sum it up, naturally aspirated engines rely on atmospheric pressure. Turbocharged engines utilize exhaust gases to drive a turbine, and supercharged engines are mechanically driven by the engine itself. Each system has its advantages and considerations, depending on the specific requirements and intended use of the vehicle. That concludes our breakdown of naturally aspirated, turbocharged, and supercharged engines. We hope you enjoyed this video and found it informative.